Let's look at general solutions now. We're given sine x plus 1 is equal to 0, 2. So in general solutions, you need to solve for x. So sine x is equal to 0, 2 minus 1. We take our constants over. So we end up with sine x is equal to negative 0, 8. We need to find our reference angle now, so we say that x is equal to sine inverse of 0, 8, and that gives us a reference angle of 53,13 degrees. Now, because sine is negative here, in our cos diagram, we need to identify the quadrants where sine is negative. I know that sine is negative in the third quadrant and the fourth quadrant. So in the third quadrant, we are going to have an answer. So x is equal to 180 degrees plus, that's the rule in the third quadrant, our reference angle 53,13 plus k times 360 k element of z. This is for the general solution. So x is equal to then 233,13 degrees plus k dot 360 k element of z. That's one answer for the third quadrant. Now our fourth quadrant answer, the rule is 360 minus, so x is equal to 360 minus our reference angle, which is 53,13 degrees, plus k dot 360 k element of z. X is therefore equal to 306,87 degrees, plus k 360, and k is an element of z. Let's try one more. We're given tan theta plus 3 is equal to 4, 7. So tan theta is equal to 4, 7 minus 3, which is 1, 7. So tan theta equals 1, 7. We need to use that to find our reference angle. So theta is equal to tan inverse of 1, 7, which is 59,53 degrees. That's our reference angle. So tan here is positive, so we need to find the quadrants where tan is positive. I know tan is positive in the first quadrant and in the third quadrant of my cos diagram. So the first quadrant, I'll have an answer. Theta is equal to 59,53 degrees plus k dot 180 degrees, k element of z. For tan, it's k dot 180, but for sine and cos, it's k dot 360. Okay, we also have our third quadrant answer. The rule in the third quadrant is 180 plus. So theta is equal to 180 plus my reference angle plus k dot 180 k element z. So theta is equal to 239,53 plus k 180 k element of z. So I have my first quadrant answer and my third quadrant answer there. Let's try one more. Cos of theta plus 10 degrees is equal to negative 0,23. So our angle here now is not theta. Our angle is this entire thing. It's theta plus 10 degrees. So theta plus 10 degrees is equal to cos inverse of 0,23. So my reference angle for theta plus 10 degrees is 76,7 degrees. That's my reference angle. I know that cos is negative. In which two quadrants? Cos is negative in the second quadrant and in the third quadrant. So I will have a second quadrant answer where the rule is 180 minus. So theta plus 10 degrees is equal to 180 minus my reference angle plus k dot 360 k element z. Theta plus 10 degrees is equal to 103,3 degrees plus k dot 360 k element z. If I want to solve for theta, I need to take the 10 over now. So 103,3 degrees minus 10 plus k 360 k element z, and my answer for theta will then be 93,3 degrees plus k dot 360 k element of z. Again, we said cos is negative in the third quadrant, and the rule in the third quadrant is 180 plus. So theta plus 10 degrees is equal to 180 plus my reference angle plus k dot 360 k element of z, and I'm going to solve the same way for theta here. So theta plus 10 degrees is equal to 256,7 degrees plus k 360 k element of z. Take the positive 10 over, it becomes minus 10. So 256,7 minus 10 plus K360K element Z. And my final answer for theta is 246 degrees and 246,7 degrees plus K360K element of Z. So those are my two answers there for general solution for this problem.